Okay. All right, guys. Luckily for, 10, look at that. We got 10. Luckily for the 10 of you guys, our lesson today is not very long. Hold on. Okay. It's not very long. We've just got another technique, shortcut, if you will, that we want to learn to take derivatives of certain functions. So we're going to go over those. Like I said, they're not really very long. And I am going to talk a little at the end about our first test coming up and when that's going to be and how it's going to work and all that. But here we are. So this is 11.6. We're going to be talking about the product and quotient rules. So I'm going to start us off with a review of something we did last time. So we had something like f of x equals, I don't know, 3x to the 5th plus 10x squared minus 2x plus 5. And we look at this, and yeah, it's got a lot of terms, but notice all those terms are either added or subtracted from each other. So what we learned last time was that we could take the derivative of each of them separately and just leave the operations in there. So that was nice, and we can absolutely do that. So let's go ahead and do that. Do a little power rule review. Okay, so first term is 3x to the 5th. What do we do with the coefficient? Remember, we just bring it straight down. So this is a coefficient of x. It's going to come straight down into my derivative. Then I do the power rule on the x to the 5th. So the 5 also comes down in front, and then the x is now raised to the 4th power. Then the 10x squared, so the 10, that's another coefficient, so it's going to come down with me. Power rule on x squared, the 2 comes down in front, and then now x is raised to the 1st power. On the 2x, so I have minus 2, because the coefficient comes down. Remember what happens to x. You take the derivative, and you remember you can use the power rule. You're going to get that x to the 0. But just knowing what we know, that x is going to turn into a 1 when we take the derivative. So really, this is just going to be minus 2. And then the plus 5. You guys remember the difference between this and like one of these. These are coefficients. They're touching an x value, so they get to come along. This doesn't have an x value, so it's a constant, so it disappears. So this is what we got, right? And then, of course, we simplify that. Let's call it 15x to the 4th plus 20x minus 2. So this is what we did last time. And that covers a lot of functions, right? I mean, we can take the derivative of any function. This could have 10 terms in it, maybe just one term. As long as they're added or subtracted, we can just do each one separately. Okay. But what if they're not added or subtracted? Sometimes it'll be all right, and sometimes it won't. Let me show you. So in this example, I'm going to have f of x equals 3x squared times 5x to the 4th. Now, the only thing I can't do is I cannot look at this, see that it's multiplication, and say, okay, I'm going to take the derivative of this, and then multiply them together. So basically what I'm saying is I can't say that this is 6x times 20x cubed. It won't be the right answer. So basically, if it's not add or subtract, you can't just take them separately and then do whatever operation it is. Multiply and divide, we're going to find today, have very different rules. Now, you might be thinking on this one, well, why don't I just multiply those together and then I'll have a single term? Absolutely, guys, you can absolutely do that. So while you can't take the derivative and then multiply, something that you might want to do on a problem like this, I mean, notice they both got the x's in there, they're just multiplied. You could put these two terms together as 15x to the 6th and then take the derivative. That would be the easy way to go. But, and that is the absolute way I would go on this one. But just as a clear, simple example of what it means to be a product is an example like this, where I can't take them separately and then multiply. So what we have today is cases like that. So cases where my function, f of x, is going to be a product of two different x terms. So both terms are going to have x in them, and that's what makes the rule apply. So I'm going to give some examples of when we have to use the product rule and when we don't, because I really, really want to make sure you know the difference. So if I have f of x equals x plus 2 times x minus 3. So notice that I could see this as a product of this times this. Both factors of this product have an x term in them. This is a perfect example of a case where I could use the product rule. If I had f of x, so I'll put a little check mark. Yes, we could use the product rule here. What about f of x equals 5x cubed? So you might look at this and say, well, that's a product. You guys, this is a product of 5 times x cubed. But because, well, this factor definitely has an x in it, this one does not. This is not product rule, right? You know how to do this. This is just a coefficient. And then we know how to deal with that. So this one, no, you definitely do not have to use the product rule here. This next one I'm going to write, we actually don't have enough info. I haven't taught you enough yet to actually take the derivative of this, but I'm going to write it anyway for example's sake. So maybe I have like the square root of x times e to the x, for example. I could deal with this. You guys know how to deal with this because we turn it into a power, right? But you guys, I haven't taught you how to deal with this yet. But regardless of that, is this a product of two functions of x? And I would say yes, because both factors have an x variable in them. So this would be an example of where I would have to use the product rule. Okay, so that should help on, do I need it? Do I not need it? Now, actually, I'm going to leave this first one up. And I'm going to erase these two because they were just for example's sake. So I look at this and I already decided I got to use the product rule here. Now, I know that you might be thinking, well, that's not really hard to FOIL. Why don't I just FOIL that out and then I can take the derivative? Remember, if you FOIL it, what you're going to get is 3 terms, either added or subtracted, and you know how to deal with that. You take the derivative of each. But guys, while yes, we could absolutely FOIL this out, to be honest, I would absolutely FOIL this out in a normal case. But the problem today is like those example, or like that last example I gave you, that would be so perfect to demonstrate this product rule, but I can't yet because you don't know enough information about the derivative of some functions to do that. So because we don't really have a lot of choice, we don't have a lot of tools in our derivative tool belt right now, I have to show you the product rule on a question that you might not actually do that way. It's not the easiest way to go, but I can't give you anything better, I guess you could say, because we just don't know enough. So let's pretend that we don't know how to FOIL. Maybe FOIL doesn't exist, and I look at this and I say, oh man, there is no possible way that I can do this without the product rule. So I got to use it. So I got to know what it is. So the first thing you want to do when you're taking the derivative of a product is you locate your two factors, making sure they both have x's in them, because remember, if they don't, you don't even need this. Take your two factors and label them. You're going to label one of them U and one of them V. Honestly, you can label them whatever you want, but I'm going to use U and V, so I would suggest that. So basically, we are going to break this up and say, okay, U is this function of x, the x plus 2. V is a different function of x. So you can see that this is the product of two separate functions of x, and when they're put together, they're called f of x. Okay, so if you want to take the derivative of this U times V, this is how it plays out, guys. What you're going to do is you're going to write down U original form, and you're going to multiply that by the derivative of V. So it's U times derivative of V plus your next term starts with V, just original V, and you multiply that times the derivative of U. You guys, this is how you take the derivative of a product. This is your product rule. So this is important to remember, but it's actually really easy to remember. So you got U and V, and you've got the derivatives of both U and V. Just match them up in an alternating fashion, right? We have original with derivative, making sure that they're not the same. So it's not U and du. You switch that around, so we have U dv. And then over here, we have an original and a derivative, but it's the other two. So like I said, it's not really that hard to remember. Think about that alternating thing that's happening. And also, because this is a plus, and because we pair them in these two ways, it doesn't really matter which one's U and V either. You guys, you change the order of U and V, this is still going to work out the same. And again, it's because this is addition, and we have paired them up in both possible ways. But you guys, for consistency's sake, I would just say I always label my first one U and my second one V. Okay, so let's use this. So it looks like for the product rule, I need the original functions, which I have. They're just right here, right? But I also need the derivatives of each of those. So let's go to the side. So anytime you do the product rule, I would expect you, well, on this one, I know it's not a lot of complication, but it will be more complicated. So I would expect that you would write some side work. Which one's U, which one's V, and then the derivatives of both of those. So over this side, I'm going to say, okay, well, U is the x plus 2. Then I'm going to find the derivative of U, because I'll need that, right? You guys, derivative of U, I know how to find that. You just go term by term here, right? So the derivative of x, remember that's just 1. This plus 2 is a constant, right? It's not, it doesn't have an x in it, so I know that goes away. So the derivative of U in this case is just 1. Let's do the same thing with V. So V is the x minus 3. So the derivative of V, it's actually going to turn out to be the same thing, right? This is going to become a 1. The minus 3 is going to go away. So derivative of V is also 1. Here's my 4 pieces. Now all I got to do is pair them up in alternating fashion, right? Okay, so let's write everything in. It says I need to start with U. You guys, if you are writing a term with more than one thing, put the parentheses around it. It's not going to matter a lot on this problem, but it might, and it will actually on other problems. So I have U times the derivative of V, so that's the 1, plus V, so that's the x minus 3, times the derivative of U, which is also 1. So from here, this isn't always a 1. It is a 1 here in our case, but you always want to distribute that out. So it's going to end up being x plus 2 plus x minus 3. And then we combine like terms, of course. X plus x is 2x. Plus 2 minus 3 leaves us with minus 1. So you guys, this is the derivative of this product. u dv. So if I say dv or du, that's just me saying the derivative of v or the derivative of u. At a point, I stop saying the derivative of. If I say du, you know I'm looking for the derivative of u. If I say dv, same thing, derivative of v. Okay, so we have u dv plus v du. So this is important. And then knowing when to use it, when you need to use it is also important. Okay, so like I said, that one was pretty simple. And yes, my go-to method on this one, I would have just FOILed that out and then taken the derivative using just power rule. But here we are anyway. After our Friday lesson, we're gonna know more stuff about derivatives, and I'm gonna be able to give you problems where you absolutely have to use the power rule. Like there's not gonna be any alternate methods that you could use. But today we're just gonna have to bear through it, right? And even though there is an easier way, we're gonna use this way because that's what we're learning. Okay, so I can't amp this, I can't amp this up very much, but I'm gonna amp it up as much as I can on this next one. So let's say I've got f of x equals, I don't know, let's do 2x squared plus 1, and that's multiplied by 3x cubed minus 4x. So when I look at this, yes, these terms in here are a little more complicated than last time. Again, I would still just FOIL this out and work from there. But remember, FOIL doesn't exist today for us. So we're going to use the product rule. I can see the two factors right here. They're usually easy to find. Usually they're broken up by parentheses, right? So I'm going to call this u, and I'm going to call this v. Let's go over to the side and find all the pieces here. So u is the 2x squared minus 1, or sorry, plus 1. So du, let's find du. So the 2 comes down, right? And then I do the power rule on x squared. So that 2 comes in front, and then this x is just to the first. And this 1 goes away because it's a constant. So du is 4x. Let's write down v. So v is this one, 3x cubed minus 4x. So dv, taking that one term at a time, I'm not going to step by step this one out as much as I did that one. You guys, the derivative of v is going to be 9x squared minus 4. So what are the pieces I need? I need u, I need du, I need v, and dv. I just have to remember how to put them together. So to take the derivative, remember it's u dv plus v du. So let's plug in what we have. So start with u, make sure you're using parentheses. So u is 2x squared plus 1 times the derivative of v. That one is right here, 9x squared minus 4. And then plus v, just original v is here, 3x cubed minus 4x times du, which is just 4x. All right, so there's a lot more going on this one than there was on the last one where our derivatives were both just 1. Okay, so from here, so one thing I'm not totally sure of is when you're doing work in MATLAB on like product and quotient rule, there's a lot of places you could leave your answer. In class, like let's say, you know, we'll time travel back to last year when I actually gave paper and pencil tests, right? This is, when I test people in class, this is actually the line where I want them to stop. Reason being is because this is the line where I can easily see the 4 pieces of the puzzle, and I am testing over product rule. I'm not testing over your algebra skills. So with that being said, I don't know where MATLAB will let you stop. So what I mean by that is, do they want us to FOIL these things out and then get, combine like terms and simplify as much as possible? Honestly, probably. They probably do. And I don't have a lot of control over that either. But so 11.6 homework will be opening later today. And, just when you get to that, you'll find the way it wants your answer. If it does want them all totally simplified, then we will totally simplify them all. If it lets you stop somewhere like this, maybe, I just doubt that it will. So we're gonna work on totally simplifying our problems, even though it's not something I would have you do on my own. So what would we do here? Well, we have to FOIL. It's interesting because FOIL didn't exist here because, I wanted to use the product rule, but here we are FOILing. All right, 2x squared times 9x squared is 18x to the 4th. 2x squared times -4 is -8x squared. 1 times 9x squared is 9x squared. 1 times -4 is -4. All right. Now, before we go on, this is a plus, so it's not going to be that important. When we do the quotient rule, we're going to find a minus somewhere in our problem. So just because this is a good place to remind you, say you've got something like this and you FOIL all this out. If this was a minus, before you even started FOILing all that out, you would need parentheses around the whole thing. This is plus, so I don't necessarily need it, but I'm still going to put them because I want us to get in the habit of parentheses. Even more than you need is great. Less than you need on parentheses is not great, right? So I am going to parentheses this whole thing. So I have 4x times 3x cubed. So that's going to be 12x to the 4th. And then 4x times -4x is -16x squared. So yes, this is a plus. This is not necessary, but I'm still going to do it anyway. Because you guys, if you make a mistake, parentheses are going to be it. They're always it. So, all right. So from here, I'm just going to combine like terms, right? That's all I can do. I've already multiplied everything out. So let's see. I have 18x to the 4th plus 12x to the 4th. So that makes 30x to the 4th. I don't have any cubes, but I do have -8x squared plus 9x squared. So that's 1x squared. And then -16x squared. So how about -15x squared? So I took care of the squareds. And it looks like all I have left is a -4. So there we are. You guys, this more than likely is what MATLAB wants as your answer. So I'll try to get in the habit of working all these out to the bottom. Okay. So there is that. That's about as complicated as I can make one of those right now. So we can move on to the quotient rule. So I'm going to start like I did with the product rule. I need to show you some examples of, yes, this is a quotient. We need to use the quotient rule, and no, I can do it another way. You definitely don't want to use it if you don't have to. So just like with the product rule, remember I had to use it when I had a product of 2 functions of x. So both of my factors had x in them. That's going to be the same standard for using the quotient rule. You're going to have a quotient, right? You're going to have something on top and something on the bottom, and both of those things are going to have x's in them. Okay, so for example, maybe I've got f of x equals x plus 4 over x minus 7. I look at this. Again, you cannot do the derivative of the top and the derivative of the bottom and just put them over each other. That on this one would get you 1/1, which is definitely not the answer here. So don't try to do this separately. This is a quotient. Notice I have an x term on the top and I also have an x term on the bottom. So I know I would actually have to use the quotient rule here. So yes, definitely, and we will do that one. You guys, I don't want you to get confused on a quotient rule with something like this, where we just have maybe like 4 over x to the 5th. It is a quotient, definitely, sure. Why don't I have to use the quotient rule here? Well, because this top doesn't even have an x in it. This is just a coefficient. You guys, I actually know how to deal with something like this, don't I? Don't I just rewrite it with a negative exponent and then use power rule and go on my way? Absolutely. So I would not need to use the quotient rule here. Let me see. What about this one? So what if I have f of x equals 5x cubed over 2x squared? So you look at this one. It's a quotient. Notice both top and bottom have x's in them. You could absolutely use the quotient rule here. Would I, though? Absolutely not. Guys, each one is just a single term. I would reduce this. Notice x cubed divided by x squared, the 5 over 2, you're going to end up with just 5/2 x. You guys, you could absolutely just do the division here and get this. So while yes, you could use the quotient rule here, it is not very efficient. So just different. So let's call this one a yes, no. I could, but I wouldn't. So you just have to be able to tell when you need it and when you don't. But that first one, absolutely we need it. So let's look at that. Ooh, and another thing I want to mention. Why could I cancel out these x's here, but I can't cancel out these x's here? Well, it's because of this plus and this minus. Guys, remember, if you have x plus or x minus something here, you have to treat these as this is one term, this is one term. So if I tried to take this x and divide it by x, I would also have to do the same thing to the 4. And I actually would have to divide everything by the whole thing. So just remember how terms like that work. You can't just pick and choose what you want to cancel out. Okay. My kids are being loud out there. I don't know if you can hear them. Hopefully it's not horrible, but they are being loud. And it makes me wonder if my 10-year-old's still in his Zoom call. But anyway, so let's move on. Oh, I just erased the problem I was going to do. That's my kid's fault. I don't remember exactly what I had. It doesn't matter. I think it was like something like this. So here we are. Let's use quotient rule. So when you're using the quotient rule, so we've decided we have to, and we're going to use it. We're going to use u and v again. This time it absolutely matters which one is u and which one is v. So guys, u has to be your function on top and v has to be your function on bottom for this to work. So, you know, products, multiplication, addition, you can switch order around all you want, but I know that with division or subtraction, I cannot. So this is this case here, because we're going to do both of those. So pick your u, pick your v. To find the derivative of this quotient, it's going to be a quotient. It's going to end up being a quotient anyway. But on top, this is what I'm going to have. I'm going to have v times du minus u times dv. On the bottom, I'm going to have v squared. So the whole function v just squared. So some pointers here before we get started. Product rule. Remember, I have these same two terms in my product rule. Key differences. This is a minus and not a plus anymore. And notice which term is first. Remember when I wrote out the product rule, I did u dv and v du. That's just the way we write that. I guess if you wanted to switch it, it would be fine. but usually we write it that way. You have to be very certain that you know which term comes first here. The term with the original V comes first. Why is the order so important? Because it's subtraction up here. So be careful with that. Original V comes first, but the pairings are the same. And then on the bottom, like I said, it's not the derivative of V or anything, it's just the original function V squared. So let's go over to the side and find all these pieces we need. So let's start with U. Original U is x plus 4. Let's find the derivative of U. That's easy. We've done derivative of something like this, right? The x turns into a 1, the 4 goes away. So just 1. Original V is x minus 7. So dV, again, is just 1. V squared, you guys, I would just write V squared as the function V squared. So I'm just gonna leave it like that, at least for right now. So these are the 5 things we need. We just have to remember how to put them in here. So original V comes first. Make sure you use parentheses when necessary. Minus is necessary. So original V is x minus 7 times the derivative of U, which is just 1, minus original U times the derivative of V, which is also just 1, over V squared. So I'm just going to write that as x minus 7 squared. Make sure that this is in parentheses if you're going to just write it like this. Okay, so from here, let's just work out the problem, right? So these are both times 1. So I'm just going to get rid of parentheses right here. So this is just x minus 7. Be careful here though, because this minus applies to both of these terms. And this one if it wasn't just a 1, right? So minus x minus 4. On the bottom, I'm just going to leave that as x minus 7 squared. All right, so this doesn't always happen this way, but you are going to notice it happening sometimes. Notice my x terms are actually canceled out, x minus x. So I don't have any x terms. If they cancel out, that's fine. It does happen. If they don't, that's fine too. It just depends on the problem. Minus 7 minus 4, we get minus 11 on top. Now, here's the deal with the V squared. It's just another one of those things we're going to have to try out and see what MATLAB likes. Paper and pencil test, I want you to leave it like this. You guys, for one, again, it shows me that you know V squared is on the bottom. And when you start foiling, it's just more chances to make mistakes, right? So this is where I leave it in class. But again, we are at the mercy of MATLAB and how it likes things. So maybe you need to FOIL this out. If you do, it's not a huge big deal. You would just FOIL it out. So you get negative 11 over x squared minus 14x plus 49. So both of these answers are correct. You figure out which one it likes, basically. And you guys, as you do start working on 11.6, let me know. You know, it'd be a good thing for me to know as you start working on it. Hey, can I put it in like that? Do you have to do it all the way out? You know, let me know your experience, and then that way I'll have more of a clue about it. So let's see. All right, so that's it. You guys, I'm not going to do another quotient rule with you. Like I said, when we know how to take the derivative of more complicated functions, we will rely on this a lot more. But here we are, and I wanted to talk to you about the fact that we are almost through with chapter 11, and that's when we have a test. So guys, here's the schedule for the next 2 weeks. This was today. Friday in-person class, we're gonna do 11.7, which is the chain rule, which is my favorite, definitely for an in-person day. But anyway, so we're gonna do that on Friday. Monday, of course, is Labor Day, so we're not gonna have class at all. And then, so Wednesday is going to be kind of like a review day, and I'll explain that here in a minute. But Friday, so a week from Friday, I think it's the 11th, is going to be our first exam. And when I say our first exam, it's going to open around that time. It's not going to be in class. It is going to be online. Reason being, guys, some of you do. I do see you in class, like you have that option, but some of you don't even have the option. So I'm not going to make an in-person test and an online test because it's just not fair and there's no equity there. So we all take our tests online, and I think everybody's probably fine with that. But anyway, so what I'm going to do is I'm going to make a practice exam. So just like a review study guide type thing. That'll be your next quiz grade. It's going to open probably Thursday or Friday of this week. I'll have that ready. I'll open it up. And because it's while yes, you're going to have it for a quiz grade, it's a practice exam. So I want you to practice it. I'm not going to put a problem a limit on how many times you can do each problem. So basically you can work it and rework it and rework it until you get 100 on it, which is great because, hey, you got 100 on your quiz grade, right? And it benefits everybody because it means that you actually practiced for the exam. So it's a win-win, right? So that's going to be up. And over the weekend, that'll be up for you to take. It'll be up, on Labor Day if you want to do that. But anyway, so on Wednesday, that review day I was talking about, we're not going to be learning anything new in class that day, obviously. So it's going to be kind of a optional, say you were working the practice exam and you have trouble, you have questions for me. That's when you're going to come ask, and then I can work stuff with you on the board. But say over the weekend you took the practice test and you aced it and everything made perfect sense, then I don't need to see you on Wednesday. So Wednesday, I guess, is going to be more like an office hours day. Come if you need help on stuff, to get you prepared for the exam. Let's see. I do want to say, though, if you come on Wednesday and you just say, can you work the whole exam with me? I am not going to do that. I want you to do it on your own first and come to me with specific problems that you're having trouble with. Not every one of them, surely. So just, do some preparation before you ask me questions. So let's see. So that's going to be Wednesday. I'm probably just going to open up the exam on Thursday. Technically, I just said it was going to be on Friday. But it is online, so I'll probably open it on Thursday. That way you have a little more time to take it. It'll be due Sunday night like everything is in this class. So on Friday, we will still have class because we don't have to take a whole class period to, reserve for an exam. You will still have class on Friday. We'll just move on with stuff, but your exam will be open. So hopefully that makes sense. As we get closer, it'll make more sense. But other than that, guys, that's all I got for you today.
Can you help me with one of the problems from the homework?
Sure.
Okay, so it was f of x
Okay, let's see. F of x
equals 6 square root of x plus 12x to the 3/4.
To the 3/4?
Yeah. And it's wanting to find the derivative of it.
Okay, so
I'm sorry, I don't mean to interrupt, but I just have one quick question. Do we need to schedule like a proctor for the exam? No?
No.
Okay. Okay, thank you. I'm sorry to interrupt.
All right, no, that's fine.
All right.
Okay, so remember, you're just going to take the derivative of each term separately. So you'll take each of them separately, and then they'll just be added together. So this one, I would change that to x to the 1/2 first. So remember, all we have is the power rule, right? So this root, change it to a power before you start. This one's already a power, so just leave it like that. And then we'll use the power rule on each of these. So the 6 being a coefficient, remember that comes straight down. x to the 1/2, that's what you're going to do the power rule on. So remember, the power goes in front, so you're going to have a 1/2 here. But you have to take 1 away from this power. So 1/2 minus 1 is negative 1/2. So that's going to be your new power on x. With this term, that 12 comes along. Bring the 3/4 down. And you have to take 1 away from this. So again, you just have to think about, take your 3/4 minus 1. So if you have 3/4 and you want to take away 1, why don't you see 1 as 4/4 instead? So 3/4 minus 4/4 leaves you with negative 1/4. So that's going to be your new power on x. And then from here, all you got to do is just multiply these two together. So 6 times 1/2, that's like 6 divided by 2 basically, right? So we get 3x to the negative 1/2 plus 12 times 3/4. Remember, this is 12 over 1. So when you look at this, you guys, you could think about taking a 4 out of this cross product here. That would leave a 3. It's going to leave you with 9. 3/4 of 12 is 9. So then you'll have plus 9x to the negative 1/4. And that's it.
Okay, I did it right, except I just put 4 instead of 6 in the beginning, so I did everything wrong because I had a 4.
Oh, no.
That's what I did wrong. Thank you for doing that for me.
No problem. All right, guys. Well, I'm going to sign off then. So I will see you in class, possibly, if you're one of those people, on Friday.